Unmute. Yeah, so hi everyone. I am Koki, and this my graduation project focus on automated floor plan optimization. It's still moving. What? All right. So my graduation project focus on automated floor plan optimization for bathroom. So why is the automation important? The automation of layout designing has been tackled in various methods since the early 90s. From then on, the architects, computational designers, and developers have been attempting to produce an evolutionary design method to solve layout problems. According to Anderson and his team, who attempted to create automated desk arrangement system, it brings the potential of increased cost performance in projects, reliability, and efficiency by systemizing repetitive tasks and works by automating a component in design in a design process. However, a universally applicable method has not been produced for computer-aided layout design. This may be caused by the wide range of focus. In addition, there are several factors affecting the building design, which kind of force the building designs to be different. There are building regulations which are set by local government and also the requirements set by the clients. This creates harder environment for the developers to generate automated layout designing system. So aims. So from the background research, the two aims have been generated. This project aims to explore the potential to implement the automated designing process to the actual project. Considering the project's duration was set to maximum 10 weeks, these are the main aims of the research. So one is to develop a script that generates practically acceptable office building bathroom layouts on Grasshopper. And then the second one is to optimize the script so that it can accept different regulations and item requirements. So research question. So to implement an automated layout design system for practical projects, it requires the high accuracy that follows the regulations set by the government and clients' requests. If the system cannot follow the regulations, there's not much point to apply to projects. So therefore, this project focused on this aspect. And so the research question became, how can automated bathroom layout designs be accurate when assessed against the regulations and clients' requirements? So this is my design objectives. So three things that this project focuses on is adaptivity. So in adaptivity, there's clients' requirements and various regulations. So the script should be adaptable in various situations. So it should be quite flexible as well. So flexibility is for location and shapes and sizes. The bathroom location shouldn't affect how the layout generation works, and then shapes and sizes should also doesn't affect, and the script should return the layouts as a result. So for comfortability, user experience and privacy is considered. If people are standing too close to each other, it will create some privacy issues. So therefore, I would try to solve these issues. So workflow diagram. So these are the workflow diagram of this project. The first is to identify regulations, item requirements, and floor plan of the building. Regulation is set by New South Wales. For this, I'm going to use the regulations set by New South Wales, but specifically for office buildings and bathroom. And the item requirements is for this project is the standard bathroom items. So after identifying everything, the next phase will be Grasshopper and Rhino scripting. So first is to define size and shape of the room. And then next is to define where the entrance is. And then the upcoming steps are finding where the toilets and wash basins are. And then the script will be optimized, and then the best outcome will be produced. So basic algorithm for allocating bathroom components to spaces. So within the provided space for the bathroom, find the interior outline of building is the first step to start the algorithm. So after find the interior outline of building, it seeks for the location to allocate a door on the side where it does not collide with other rooms and building wall. And then after allocating a door area, there will be two spaces. One is leftover space, and then the other is allocate the area for wash basins right next to the space of the door. So this leftover space will be now divided into two sections again. One is space for cubicles, and then one is another leftover space. So the last step is to allocate space for paths, and then if it's a male's bathroom, allocate the space for urinals. This script works under a premise that the outline of bathroom is provided and predefined. They tend to have rectangular shapes, so the rectangular shapes are used as the standard for this project. Yeah, that's a script. This is a script that I generated for dividing spaces into segments for components. This first component divides the overall bathroom space into two big segments, so which is this one. And then one segment will be used for door and then wash basin. And then the other segment will be used for cubicle and paths. So this section is dedicated for door and wash basins. And then the other sections are going to be used for cubicles and paths. So involve algorithm for allocating objects in spaces. So the items of bathroom except the entrance door, the scripts. In this phase of script, the components of bathroom figured out in the research phase are going to be allocated to the defined spaces. The space division phase, binary tree-like algorithm. In this phase, the algorithm will the base algorithm is designed with a combination of if loops using simple Python coding. So this is the flow of algorithm. It calculates how many objects can fit within the space first, and then test aside if it is favorable for allocating the objects. If it's not favorable, remove from the list. And then, if it is favorable, divide the space into the amount of objects needed. Allocate the objects to divide the space is the next step, and then test if objects are properly arranged to the allocated space. If necessary, move and rotate objects. So this process repeats until all objects are properly arranged. If it's not necessary anymore, it is the end of algorithm. So this is the script for item allocation in Grasshopper. So the first importing a model for a component would happen in this section, and then it takes the bathroom outlines, and then it finds out where the best location is for the components to be allocated. And then this section shows the rotational script. And then the last part is conditional script. This only works if the items are still located outside of the building. So this is Grasshopper script for object allocations. So rotational allocations. So this is the inside of the cluster in the previous screen. So in this one, it has the Python coding, and it is based on if and elif script. So if the number of points of items are more than 2, it will return 180 degrees. And then if this one component, which is outside of the space, it will return 90 degrees to rotate the items. So this is the working example of the script. So by changing this number, it changes the room size. And then as the result, the room layout will be produced. So these are generally works for almost all the shapes and sizes. By turning this on, it becomes the male's bathroom. And then to change the location of the bathroom, this slider is used. So this is to check if the layout algorithm works for different shapes and locations. As you can see, it is working. So outcome of script. Generated layouts have a functional outcome and they support both male and female bathroom. And then it can possibly can utilize more of the path space. So when the overall bathroom area gets huge, the path space tends to be unutilized, as in like there's no much use for the path. So this space could be improved as the result. So future works. So what is already achieved? So it supports standard commercial building bathroom layouts and then female and male bathrooms. Then the inputs are adjustable. What this means is like it can change. Architects can change the inputs, as in the models and then dimensions of the bath toilets and then urinals and other things. So what can be improved? So as I mentioned earlier, efficiency of unused spaces could be improved. And then ambient bathrooms could be improved. Could be installed in the bathrooms too. And then by supporting other building types, it can increase the versatility of the script. Therefore, it increase the value of the script as well. Yeah, thank you for listening. This is the end.
Well, thank you. One quick question. Some stage it looks like the space between the washing machines and the space before the front floor. You also have a unpaid space underneath the floor.
Let me just go here. So in this section, it shows the water tap wash basin area is defined by the length of the door space. So by increasing the space of the dimension for door, it could potentially to increase the water tap space as well. So it is simply it can be changed very easily.
Thank you. So 11, probably you have to request control.
I think I can just share.
Then just share, perfect. Yeah, and we can hear you as well.
I'm making a full screen. 1 second.
Yep, looks like it works.
Yep. Cool.
All right, good.
Yeah. Hello everyone, I'm Levin. I'm working on my project called the Space Games Competition and Collaboration in Multi-Agent Reinforcement Learning for Automated Apartment Floor Plan Generation with my industry partner HDR. And a bit about my research background is that the problem that I'm focusing is a problem called space layout planning, which is 60 years old. And throughout the years, mathematicians, computer scientists, and architects are trying to find the ultimate solution to this problem is by automating the generation of the floor plan. And the solution that they came out with are not perfect. The results that they have still needs minor manual adjustments. So I'm here with a new method in machine learning called multi-agent reinforcement learning, trying to fit this method into this problem and find and try to find a perfect solution for this problem. And here's my research question. How can multi-agent reinforcement learning be more efficient in numbers of layout generated and accurate in realistic aspect of plans when applied to unit layout inside of a mixed-use residential building? As you can see, this project is mainly focused in small-scale residential buildings, but it doesn't limit the possibility to go large-scale. Here's the aims of my objectives. So 3 objectives. The efficiency is the full land coverage that the floor plan generates, leaves out no blank areas. And the second is the generation speed for a successful plan. Talked about optimization is that the plan will maximize the area to receive solar access in winter and has occupied at least one cell next to corridor for corridor access for each unit. And the realistic factor is that the shapes of each block are realistic, so they won't be interlocking too much. And here is a picture of a very simple example of a ending results I wish for. And here's about the literature review for reinforcement learning. As reinforcement learning is an area of machine learning that deals with how to learn which actions to take in a given environment in order to maximize a given long-term rewards. That is written by Sultan and Bartow in 1998 in their book called Reinforcement Learning and Introduction. And here you can see a diagram that shows the process or the loop for reinforcement learning. As the agent or the AI gives an action to the environment, and the environment will act based on the action that's given and send the information about its own environment into the interpreter, as the interpreter will give the rewards or a punishment to the agent, a negative value for punishment and a positive value for reward back into the agent, and sending the environmental state back into the agent as well, and the loop continues on. And the agent's aim is to maximize the area, maximize the rewards for its own good. And here's about multi-agent reinforcement learning. The 2 gifts on top is the OpenAI hide and seek experiment. As you can see, they work collaboratively and competitively at the same time in the same environment. And you'll be wondering, how is this going to fit into the problem of space layout planning? And here I propose that if you think about a unit as a snake, which is from a classic Atari game, and fitting multiple snakes into the same environment and let them grow into a unit shape, and they will produce a successful plan. And here's the workflow. There's 4 main components about my workflow: is the input, the environment, the action, and the reward system as the fitting objectives. I'll be talking about them shortly afterwards. Here's the input. There's a defined boundary that's required from the user as the floor plan layout boundary line, which is processed into Rhino and Grasshopper to be divided into individual square grids, approximately 1 square meter per grid, and then running into Ladybug for a solar analysis and to help the user to identify their core block position, which the core block consists of the staircase, 5 staircase, elevator, and the corridor. And all this information will be put into a CSV file and to be used later in the Python codes. And here's the action that the agent will choose. The agent will grow into blank cells with 4 directions: up, down, left, and right. And as you can see, there's 2 versions of it. As the version 2 is more updated, it allows interlocking to happen in the environment. And the second action that we have is that the agent will withdraw occupied cells from 4 directions. So they will be able to move along in the environment and choose their optimized positions. As you can see, there's a 2x3 shaped unit. It will be allowed to withdraw horizontally and vertically. The 1x3 will only be allowed to withdraw vertically, as when it withdraw horizontally, the whole unit will be cancelled out. And here's about the Python framework that I used is called Tensho. It is a very young and beginner-friendly framework for multi-agent reinforcement learning. What it does is that it responds the agents, allows the agents to take actions and fit all the reward rendering functions and limitation and constraints for agents into a same environment that sends the wrapper to its own interpreter. And yeah. And here's the reward function. As I've said, it's based off the objectives. So we aim for no blank cells and maximize sunlight in at least one corridor adjacent cell occupied corridor axis. So the rewards will be consist of the numbers of occupied cells. This is based off a max limit and a max and minimum limit for the agent to occupy. As when it goes over the maximum and gets less than the minimum, it gets punished. And the corridor access cell is that when it doesn't get any corridor access, it will be punished as well. The number of solar access cell, that means if it doesn't get any window cell, it will always get punished. And here's some results from my my framework, my project. As you can see, the agents are developing itself to suit the objectives, but it's not perfect. As you can see, Agent A learns the importance of corridor access as they try to occupy a lot of corridor access cells that's next to the core block. And B is trying to occupy all the window cells, which has the highest solar access rewards. C just doesn't know how to grow. D understands the basic needs of a window cell as it grows to the corner of the building. And here's the second result, that the punished is multiplied by 10 and 100. It shows the exact same results. As you can see, C starts to understand the importance of its size, its solar axis, and the window cells. And B, turns out it doesn't round the solar axis anymore. It went for the corridor axis and its size objective. And A learns about the importance of corridor axis as well. And D just lost its interest to escape from C's trapping. As you can see, it's trapped within C. And here's the results that has the punishment multiplied by 1,000. And all agents are being punished too much to understand any rewards or any objectives that they have to achieve. And here's the evaluation. The limitation of the current model is that Tensho is a very lightweight and beginner-friendly reinforcement learning library, but is limited in some applications. As I've talked to the developers of the framework, that they have not tested to train multiple agents and write multiple policies of each agent at the same time. And you can see from the results, only the results that's multiplied by 10 and 100 shows the best results, as agency understands most of the objectives. Future development, the rewards function definitely with some refining and adding viewpoint rewards for, as mentioned by my HDR industry partners, and adaptation into Grasshopper for visual representation. As you can see, the binary or the characters that shows the floor plan isn't very visually pleasant. And the shifting from Tensho to IO Lab as a base library for training, as it is a more developed framework. And here's the thing about this project that will be used in large scale. It is not definitely limited in small scale projects like apartment floor plan. It can be used into aspects of master planning, as each agent will represent a building or an aspect within the community. As you can see from the graphs over here, each agent can represent a block of color and create itself within the boundary to find its very optimized positions. As it may be even possible to be used in a 3D space planning. As you can see, the area, the buildings, you can see there is that the bottom floor is for shops and for access, and the upper levels are for residential. So the agents will be able to be working in a 3D environment rather than only 2D. And thank you for listening.
Good, thanks for your presentation. Can you hear me?
No, I cannot, sorry.
I come quickly to the front so you can hear me. I think that one is video on. Thanks for your presentation. I think I agree the visualization at the moment it is very, very abstract to understand. So that would have been an important point to do so. What made you move from the Tenshu to the RLB library move? What was that motivation for buy?
The Tenshu library is very underdeveloped. It's only published in beta in April this year, so it needs a lot of development in the library to match up with our lab, which is published in 2018. And it's very developed a library it has like multiple authors for this framework.
Okay, good. Thank you. Jinan, can you please take over?
Yeah. Hi,
Can you also please? There were comments before. Put your video on if you got. So we actually know who's presenting instead of having a video clip of an empty gray wall in there. Thank you.
Hi, I'm Junanti. My research project is automating bathroom layout designing, and the first is research background. The space layout design is one of the most important stages of architecture design. With the development of digital technology, the automated layout is more and more applied in architectural planning. Compared with the traditional space planning method, the automated layout has high efficiency, and the automatic generated space layout has shown great design potential. But the current automatic space layout still has some limitations. The current automatic generated space layout lacks the flexibility of location and shape selection. My research question is how to make automatic space layout more flexible. And my objective is respond to the needs. It includes class requirements, regulations, and legal. And this is my project diagram. The first is research, the second is modeling, the third is analysis, and the fourth is scripts, and optimization and outcome. And I use tool is Rhino and Grasshopper. And the first is research. And first is regulations and legal. According to the regulations of Safe Work Australia, the number of bathrooms depends on the number of employees. These practices are designed to prevent long queues and ensure that employees can quickly use bathroom facilities. Through the above research, it can be determined that the first task of this project is to design an input system so that the user only needs to perform simple operations in the layout system and directly enter the required numbers to obtain the corresponding number of bathrooms to meet the above rules and laws. And another goal of this project is to meet the needs of customers. So it is very important to collect their opinions. For this reason, I conducted a questionnaire survey on 25 randomly selected staff. Most of their working environments are different, so such survey results are diverse. After sorting out the questionnaire, it was found that 36% of the respondents believed that good ventilation in the bathroom is very important. And the second important issue that users pay more attention to is to hope that the bathroom can be close to the work area. So at the times spent in this aspect that can be reduced. At the same time, some users have other needs. Through the above investigation and research, it can be determined that the second problem to be solved by this project is to allow users and designers to change the location of bathrooms at will by using this system, so that they can base on the location of windows of the building, and the location of the work area and other. The condition is to change the location of the bathroom to meet its requirements. And the second is modeling by Grasshopper and Rhino. Because all layout work is carried out in an existing building. The second step of the project is modeling, and as an automatic layout system, it must be able to adapt to different building shapes to get a complete layout. Therefore, through Grasshopper and Rhino, I built many different shapes of building growth to provide the basis for the design and testing of the next project, and to test whether this system can be selected in different areas for layout. I also established a complete building layout, and this is scripted by Grasshopper and Rhino. And according to the design goals, the first thing is to design an automatic layout system that can adapt to different building shapes. In order to achieve this goal, Grasshopper and Rhino were used in this design. By analyzing an existing building plan, the system can be used to lay out the bathrooms in different buildings, since the location of the bathroom is not only on the edge of the building, but may also be located in different areas within building. By separating different areas in the building, the user can select different areas and then proceed to the layout of the bathroom. And the users can see the real-time results of the layout. And In the first iterative analysis, it is concluded that the main task is to solve the problems of the number of bathrooms in order to meet legal requirements for bathrooms. Specifically, users can change the number of bathrooms according to different needs. In this term, users and designers only need to enter the number of bathrooms according to their needs. In order to meet the needs of the users for the bathroom, the main task is to allow users to change and determine the location of bathroom at will through this system. In system, the user only needs to slide the slider to change the position of the bathroom at will, and can control the positions of different bathrooms separately. And in this way, users and designers can change and determine the location of the bathroom according to the location of the buildings, windows, and location of work area, and other conditions to meet the requirements of the laws and users for the ventilation and lighting of the bathroom. And in addition to the above design, in order to meet more needs of user, I also made a design. In this term, the user can also directly control the size of different bathrooms by moving the slider. And this is conclusion. The advantage is achieve the goal, and the second is have flexibility. Flexibility is includes adapt to the some shapes, location, change location, change count, and change size. And because there are many different building shapes, it is impossible to test in each building's shape during the research process. So it is not sure whether the system is suitable for all building shapes. Secondly, through the collected laws, we can know that the number of bathrooms is determined by the number of employees in a company. So therefore, a system should be designed in which user can automatically determine the number of bathrooms only by directed input employees. And next step and future work. In the future work, solve some the problems that have not been solved. Improve the current script, make the automatic layout work more flexible. Can be in a variety of different situations, get best results. Thank you.
Hi, can you hear me?
Yeah.
Okay, thanks for the presentation. I have a couple of questions. The first one would be, how are you calculating or analyzing the ventilation and the best location for your bathrooms? Because you didn't explain like the process. So I'm not sure how you said that you're locating the bathrooms depending on to have the best access for the users and then also to have the best ventilation. But what have been the process to calculate that two parameters in your script? It could be good when explaining that. It could be good to have a diagram showing like step by step what have you done to calculate the best location. If you have been using, if you have been measuring the distance from the center of the bathroom to the workplaces of the users, or how did you do that?
If you can't find it in the moment, then maybe we're going to continue the next person here.
Sorry, I can't hear clearly.
Yeah.
So we are a bit kind of pressed of time. If you can't really find the file you want to show, then I would say we're going to leave it that way and going to move on to the next person.
Okay, I will open it.
So Renji, I think you've been the next in line.
Yep, can you hear me? Hello. Can I show my screen now?
Yes, please, yeah.
So, could you see my screen?
Yes.
Okay. So, good afternoon, everyone. My name is Rujian Chen, and today I'm going to present my final presentation, Automation Environment in Office Building. And for the background, according to the different field research that figure out that most of the office worker who works in the office building will spend nearly 75% to 85% of the whole day in the office. It is a really long time to do the indoor working. Long-term indoor office is a psychological and physical test for office workers, so they pay more attention on how to improve their office environment, try to make a comfortable space for the whole day working. And it is worth to research on the topic that could potentially provide solution the situation. So for the general direction of the whole final project was how do we improve the impact of the automation environment on office buildings. But after serious deep research came out, the question is how could the pipe system in a building be automatically arranged and evaluated. For the aims of the project is using the existing information to optimize the whole pipeline designing, and want not only work out this project but try to make a method that can generate the best pipeline design when the designer working on the office building project. So for the literature review parts, different with the residential, the office building energy using is dependent on workflow. So the office building need to consider process dynamic and the unpredictable nature. And for the research part, for the first part, I was trying to figure out how the pipe system could be distributed in a building automatically, and I used the AC pipe as the example and calculate the best path for the pipes in the Revit. That's a picture showing, and several factors has been taken into consideration when doing the pipe calculation, such as wind speed, noisy, and the pressure, and so on. And there should also be an evaluating system for the outcome, but I have not perfectly the evaluation system. So at the present, the automatic pipeline calculation and the evaluation system or methodology based on the Revit and the BIM technology has been preliminary, working to some extent, but there are still some limitation for the research mainly and on the evaluation system. According to the project, I was using the decoding space to generate the surrounding area for the whole office model. It is a toolbox using in the Grasshopper. It is a collection of analytical and generative components for algorithm, architecture, and urban planning. Sorry. Here is my working flow. So before that I was researching for the project topic and design rules, set up the modeling in the Grasshopper and Rhino, then do the calculation to work out the number of the lifts, the area of the lifts, water pipe area, and the ventilation area. Then for the calculation part, maybe need to change some data to change some data with the other group, and yeah, if not match with the other group, I need to redo the calculation again. Then come out the logic as I mentioned before. For this project, need to not only to finish this project can work out a logic that can calculate in other like office building project, then do the final presentation. That's my whole working flow. And this is the area which I was using the decoding toolbox to generate the surrounding area. And here is I set up the building surrounding my office building modeling. The blue one was residential, and the yellow one was office building. Until today, I still cannot plug in the ROPS office building. So I set up I just set up my own one office building into the whole project to generate the whole final project. And here is my calculation process, and all the calculation results are based on the office building designing standards. Then can come out the result for the scenes. And these two pictures showing is the lift area and the number of the lift, and the factors to be considered for the design of the elevator room are the number of the floor in the entire building and the area of the each floor. But the level of the building is mostly important factor to decide the number of the lifts. Yeah, and this part will come out. The result was a water pump, the water pump area, same as previously lift areas. Need to think about the level and the total area for the whole building. Then can generate how the water pump area, how big is it? Then is here is the population part. According to the previously generate the surrounding area environment, I work out if in this building the permanent population is 6,756, and for the floating population in my office building is 4,676. 78. Then consider the population, the level, the area, the area factors. Came out if in my building I need to use like four lifts, and the total area for the lifts code is 800. So this part is working out the water pipe area and the AC pipe area. So for the water pipe water pump room area is in my building is 60. For the pipeline is 120, and the AC pipe for the total area is 124.5, and for the AC pipe room need to 30. But not my office building model is different with Barangro International House. My one has some room in that, not the open space. So for the room AC pipe area is 94.5. Yeah. And for the evaluation parts, so as I mentioned before, still failed to apply the model from Rob, and cannot run the GeoJSON parts into my whole calculation, and still got some problem on the research on the standards. Maybe still got some mistakes on the calculation result. And but the good part is a whole methodology and the workflow about how BIM and the parametric design could be applied to real projects, and learn a lot about the research combined with the scripting. And for the potential work is figure out how the script from Rob's work and combine with my script. Yeah, that's most important things for the future work. And potentially we'll try to work out the scripts that could generate the pipe based on the calculation result. And thanks for the watching.
Thanks for the you would have shown in your presentation with the power design how those floor areas or the lift areas affected the floor plan of the tower. I did not really understand why you used coding space to generate an urban area around your building. Why was that necessary?
Cause what I'm thinking was I want to think about the surrounding environment, and we'll think about the population in the building. That is, I think that is a part to think about the lift design.
But normally when you get a building, you know, my building is surrounded by hundreds of people because it's a CBD, but still the amount of people that goes into my building is the amount of people who owns an apartment there. Same for an office. It's not that the train station where a higher number of people could go. So I don't really understand the relationship between those two numbers.
Sorry, Hank, I cannot hear you clearly.
I'm uncertain why the two things, the surrounding of the building, that the population that lives in that area has been relevant to the interior of a residential or commercial building. Because in both a residential or commercial building, it's a private building, the exit private building is limited.
But the population, I think, is a connection with the number of the lift, not the area of the lift.
Now the number of lifts is related to the amount of the floor size and how many people you've got per floor size.
Oh,
not
okay.
The amount of external people.
Okay.
Anyway, thank you for that. The next one, please. So how come you the next, please?
Yeah, could you hear me?
Yes, I can hear you.
Yeah, so could I start to share my screen now?
Yes, please.
Okay. So can you hear the PowerPoint here?
I can see the PowerPoint, yeah.
Okay, okay.
How John, I never knew you looked like that. How's your baby? I think we lost Howard John. Not sure where he is. Howard John, you're back again? Yeah, looks like. Andrew, give up. Occupy the screen or you present.
Sorry?
Howard John, can you present now?
Yeah, yeah, I'm here, I'm here. So could I start or?
Yes, I think.
Okay.
So you want to start? So go in presentation mode and then start, please. Given that how John got some technical difficulties and we enjoy seeing Andrew's fridge and bathroom door, can we get, can you present next till how John figures out his problems?
Yeah, sure.
Good, thank you.
Should I start now?
Yes,
Oh,
please. Yeah.
okay.
Yeah. I'm sorry, got a little bit problem with the internet. So I think now it's okay. Yeah, so could you start?
Now, we just let Kanchi start now. So please gonna prepare your internet and then join later again after Kanchi's presentation.
I think the internet is okay now, so could you start?
Then start, please. Yeah.
Okay. Yeah, and could you see the PowerPoint here?
No.
No? Yeah. Could you see that?
Yeah.
Okay, so I'll start. Yeah, hello everyone, and I'm Hao Tongbu, and I would like to introduce a kind of BEAM methodology to you. And basically, my topic was about how could BEAM be applied into multiple or complex surfaces into with BEAM technology and coordinates. Because I'm personally very interested in BEAM, and I think the technology could be very helpful to my career. So I choose BEAM as my research topic. And basically, my research question was about how could the technical problem could be solved when BEAM coordinates is applied into some complex surfaces or buildings like this building designed by Zaha Hadid. It's a Galaxy Soho, and how could the BEAM technology be applied to these complex buildings? And also there are some risks in BEAM coordinates technology, like the different standards from different disciplinary. So how could we solve these risks? And this is the two of my question. And I was mainly focused about the first one, is how to solve the BEAM coordinates in complex buildings. So my aim was in the research stage, I was aiming to figure out a methodology that could solve the problem when applying BEAM coordinates to some complex buildings. The outcome could be a script or a software or some software combined together used as a method. And in the literature review stage, I have checked a lot of essays, and I found that the main data runs in BEAM. In BEAM platform is binary data, and the main data runs in model or NURBS data. So it could potentially build up an algorithm system or a software or API to convert these two types of data with each other, so that the complex surfaces could be very easily changed into the modeling platform. And in my research stage, I was using research on the Dynamo in Revit model, and basically the Dynamo could convert NURBS surfaces into Revit objects, and basically the logic is extracting a series of position points as a reference point, and then build up the surface. I'm not very familiar with the Dynamo. I just research on it and try to do some examples. So, and then I was trying to combine the Python script with Dynamo, because every surfaces in the Revit should have their own attributes, but how we could finish that is we could get the detail in Revit and then get their own attributes. So if we have Excel, we could read the attributes very convenient. So maybe you can combine Python with the Dynamo, but I cannot manage to do it in the current stage. So conclusion is the Dynamo could be applied to complex model beaming to some extent, but there are still some limitations for me, yeah, such as the attributes arrangement and the controlling of the Python language in Dynamo. So in this practice stage, I was using grevit as a tempo, and mainly the Dynamo as another tempo, and I also use SAT files, but it's not a plugin. Yep. So basically the workflow is this is the brief workflow that maybe I could get a model from my colleague or from my teammates, and I would convert this model into test data in Revit platform, and then generate some test report. So this is the whole workflow once we got the model here, this model could be kind of multidisciplinary in structure model, pipe model, or decoration model. And also there would be multiple formats like Rhino or SU or Grasshopper. So the first step I would do is generate a script that transform this model into the unit format, and then extract the data from the model, and then pass them into Revit and do the test collision and the collision test, and then I would generate a report that about the where we have the collision or where we could not realize it. And maybe if there's some spare time, I will do a script that change the model. So basically I have three methods. One method is Grasshopper to Revit via grevit. One is random model directly to Revit. We use SAT files. And the third is Revit plus Dynamo. So firstly, the grevit work, because I could not manage to do the ROPS model, so I do my own model. And this is a grevit one, because firstly I get a simple model from my colleague maybe, and I would transfer them into the type that grevit needs, and then I would pass them to grevit layer by layer. Yeah, and with their attributes, because we have this kind of ceilings, floors, or columns, they have their own attributes. So it's very easy to do the collision test in via grevit. But and then I have tried the SAT file. The SAT file, I export the SAT file to the Revit. The model is a whole model, all have this whole groups, and they do not have their own attributes. Or saying that they will not show this is the column and this is the ceiling, but it's potentially could do some very complex models. And this is a building model I have done before, and I have tried to pass them into Revit with SAT file. Yeah, and the third one is about the Dynamo, because the Dynamo, via the Dynamo, we need to build up the small surfaces as a family, and then we need to extract the point to arrange these small surfaces into a whole complex surface. But I just do some very easy examples in Dynamo, yeah, and they kind of work. So I would evaluate these three softwares. grevit, first, the advantage of grevit is it has very instant feedback, and we could change the model. Actually, we could change the model instantly, and then it could feedback to the Revit. And but the limitation for the grevit is about how it could apply to some very complex surface or some curvy things. I think this is a limitation for the grevit, but it's really convenient for testing, because we could change the model every time. The SAT file, there's no limitation for the complex surfaces, but it's missing the attributes of every part, and it's not adjustable. Yeah. And finally, it's Dynamo. The Dynamo is no limitation for complex surfaces. But I think there's maybe no drawbacks, but the drawbacks for me is at this stage it's hard for me to control that. So the potential work, I think I would firstly try to combine grevit with Python that solve the limitations for grevit. And secondly, I would try to combine that with the model from Rob. Yeah, and this is how my presentation. Thanks. Yeah, I've finished. Yeah. So, yeah.
like when you have struggles to take somebody else's model at the beginning, with Rob's model, that your workflow has a few issues in there, because at the beginning you have the premises that you will take anybody else and just take that grasshopper thing into service. What was the main problem with Rob model?
You mean from this model, from here to here, this script? Yeah, I think the problem could be, sometimes the model, they are not, someone could pass me the linear, could pass me the curve model that maybe made from grasshopper, and someone would have a kind of a solid model made in Rhino. So they are not the same things. And how could I think this is kind of a little bit hard for me. Yeah, because if they got like a curvy wall, and how could I extract the surface or extract the main lines or middle lines or the structure lines from the surface, from the curvy surface wall? I think this could be the difficult part for me, I think. Yeah.
Okay, wonderful. Thank you. And then Kang, we're going to move on to you, please.
Okay.
Kenji, can you please present?
Oh.
Yeah, we can hear you.
Okay. I'm Kang. For my project, the title is Evaluating Workflows from Rhino to Revit BIM Data Exchange in the early design stage. Today, in the architectural field, the building information modeling and the parametric design tools have become critical industry invention tools by the Industry 4.0 influence. And the design workflow, which includes the design exploration and the construction information, could be called as the parametric BIM workflow. But there are also some collaboration problems between them. That's because the design thinking between BIM and the PD tools is totally different, such as the BIM tools are committed to adding detailed information to improve design problems and king size graphic design systems. But the PD software focuses on more complex solid geometry development. So it causes lots of BIM data exchange and interoperability issues between them. And this page shows the iteration of the research questions. For the aims of the project is to improve the design methodology and enhance the collaboration and the data management ability between PD and BIM tools. For the outcomes, it might provide a new way to help staff to reducing wasting time and enforcement on non-design and technical interoperability issues. For the objectives of the project is to create an architectural model in Rhino 6 and use it to evaluate the different possibilities of the model coupling in the BIM environment. And for the Rhino inside Revit and the Convenient, these two collaboration platforms played an important role in the research process. There is the project diagram. It's an overview of the workflow. It's for the research, study, analyze, and testing, and the summary. This page is showing the completely workflow, and there is also the first about research for platforms, research for the user's real requirements. And for the second one is to using the DWG, 3DM, and ALs to testing the results. And also at the end is time to analyze and do the summary. And this page is showing the project timeline. And for the import element type, it could invite it into common architectural elements and the custom architectural elements. There is a war example. And for the transformation method, there is a Marinode import method and direct shape import method, and also the loadable families import method. First of all, there is the testing model. And there is the DWG import results. For the analyzed table, the 0 in this table means no spotted, and the 0.5 means it's just work, but not good, and the 1 means excellent effect. There is the case study to SAT fields import. For the process, it's called whole modeling to several parts and import it one by one. And when we import it, we also define it and choose the materials. There is the results. Here's the analyzed table. For the case study 3 is random 3D force import, which is very similar to the site import. But the mesh could be used to import 3D files and rebuild the wall and floor by choose surface in Revit. Of course, directly create a family to import is okay. For the convenient direct shapes import, go at measurement and rebuild native elements. Well, it's also much easier method. We can if layer has the correct material, it will be auto updated to Revit. For most of the common elements, it will be auto changed to Revit native element. Because many architectural elements there have been changed to Revit native elements, so we can easily change the types of the architectural components in Revit. And for the additional information, it's not good enough to show. For the case study file is about the conveyor loadable family import. We can create a block in Rhino, and the conveyor could read each layer's information of the blocks to create Revit families. Here is the results, and we can see the information things is like a completely family, so it's good to use. And about the analyzed table, it's just like met the most of the users' requirements. Case study 6, random direct shape import. The random inside Revit could load random data and Grasshopper as an additional plugin into the Revit memory to run. And it also allowed to use Grasshopper to define and send elements from Rhino to Revit. As the results shows, we can see there is some like accuracy problems. And for the analyzed table, case study 7, the Rhino inside Revit loadable family imports that could allow people to create and define Revit families by reading the Revit family template file in Grasshopper. And it also supports the subcategories. For the results. And for the analyzed table is showing the random inside Revit loadable families import could meet the most useful requirements, but it also need a high time costing and skills requirements. For the comparison and the summary, in the first table, the green square is showing which import method is good and have a good effect for which problem. And for the red things, it also means like totally unsupported for which problem. And for the yellow one, it means like just worked but not so good. And the table under here is the overview table. For the unity of the chart, the time costing and the requirement to skills here are changed to the time saving and the accessibility in the skill table. About this bar chart here can clearly show which import method works best in which aspects, such as the convenience. Performance in the automation is the best one, which also means it can automate more process. And in terms of the flexibility, the random inside Revit can provide more possibilities for subsequent and modification to the native Revit family. For the second bar chart is showing which workflow solution is good at which aspect. And the black bar means the total score. So the convenient loadable family import method should be a good choice in most equations. In the end, here are some reader charts to help you read the information. And there is the overview reader chart and the manual chart. The comparison shows that the solution based on the native data format has the better performance. This applies not only to Rhino and Revit, but also to other possible tools and platforms. Conclusions and discussions. This research analyzes and evaluates the process and available resources from 7 parametric BIM workflow model copying solutions. At the beginning, a Rhino building data model that fits the actual sensors was developed from further exam and analyze collaborative process from Rhino to Revit. Then list the common usage requirements as the evolution items from practical perspectives. And the evolution process is based on 7 aspects. It's like accuracy, feasibility, and automation, interoperability, and time costing and required skills. As a result, even if the final effect is the same, each workflow has its own shortcoming and advantages. And the users could choose the most suitable parametric BIM workflow solution based on their own needs. Regarding the collaboration, if the file locations of convenient or Rhino inside is changed to a cloud drive such as the OneDrive or Google Drive, it will meet the needs of the team collaboration in most situations. And this project only including and incorporating exciting technologies for the sharing of BIM data, rather than creating a new transformation technology solution. However, no further studies and statements have been carried out because of the impact of time and paper length. And for this project, it also offers a new paradigm research study that enhances the process of design. It not only allows more user-friendly and convenient transfer of information, but it also increases the interoperability of the industry. For example, non-computational design workers have the ability to edit model information, and the result leads to reducing the time and the resources expended by staff on non-design and technical interoperability issues. And it also helps to improve the communication and data management ability between architecture and engineering and construction. This will help refine communication process and allow us to concentrate more on addressing practical issues and the design itself. For more comprehensive evolution and analysis, it should be a better choice to use a model which from agricultural project, I mean the real project for testing. Also, the cloud-based collaboration software such as the Gravate and the Speckle performed poorly for complex sort geometry. But the working mode of the cloud-based collaboration platforms is more consistent with the Industry 4.0. That's all. Thank you for watching.
Thank you. Being a bit conscious of time, just only one comment. You've done quite well because you looked into individual or the 7 different components or elements to transfer data from one problem to the other. You investigated them and analyzed them through quite nice metrics. And at the end, you really been able to give us insights on what would work best in each condition. So thanks for that. Well done. We're going to continue again with the physical presentation. I'm quickly going to hand over. So thanks, Kenji.
Thank you, Hank.
Yeah. Hi, I'm Blair. I'd like to give you a presentation about my PhD thesis. The title of my research is Lost in Translation, Achieving Semantic Consistency of Name Identity in BIM. It is an industrial collaboration between the UNSW code and the Cox architecture. With the development of computational design methods, the building information modeling, or commonly referred as BIM, becomes pervasive in the architecture industry. As a representation of data management in design projects, BIM is supported by the semantic parameters stored in the building objects. Among all those parameters, name is a primary identifier for BIM items. But it is observed that the room naming in architectural documents is typically diverse depending on the user's preference, which leads to unavoidable conflicts and misunderstanding in workplace. Take a real-life example here. If people rename the toilet into a loo in a document, the computer will suppose there are 2 different rooms, but they are basically the same thing. This inconsistent room name also makes the computer raise the difficulty for computer to pick the desired building information automatically, which however, work to keep the name consistency error. But luckily, the repetitive naming task can be replaced by computer through applying the natural language processing, or referred as NLP, which is a subfield of artificial intelligence for training machine to understand and process human natural language. Going to this project, the research aim was to try and develop a computational NLP framework to alleviate language confusion of inconsistent names within design projects, making the room name more uniform and explicit. How can we maintain the naming coherence in architecture projects? There are countless times. Oh, do I need to start again? Oh. Sorry. Can I start again? See here. Yeah. Oh, yeah. So just. Oh, yeah. Yeah. So just start from now. Oh. Yeah. Okay. So what I'm talking about. Okay. Going to this project, the research aim was to try and develop a computational NLP framework to alleviate the language confusion happen in the design place. And how to make the room name more uniform and explicit. How can we maintain the naming coherence in architecture projects? There are countless times when working on a project with multiple colleagues in which the naming diversity caused distractions and lowered the productivity. So we try to see if this issue could be solved by computer. In terms of the actual development of this research, it explores an accessible method to address the research issue from two aspects. First, a custom corpus for storing and accessing the architecture terminology. And you can consider corpus as a large word database used for computer programming. And second, a web API named UNSW naming for name standardization. The proposed API offers flexible access for users, which can be applied across various platforms like Rivet or Rhino to facilitate name consistency. The two main developments described above work in parallel for achieving the standardization. Beginning at the random input from users, the system devising an automatic normalization approach, as the traditional dictionaries are unavailable for handling the specialized concepts in AEC industry. Developing a domain-specific corpus is of the essence in achieving the accurate standardization. The proposed system enables to detect the word relevance and approach the room's classification based on their similarity. Hence, the inconsistent room name will be aligned with the defined standard. For standardizing those messy names, it's necessary to train machine to be aware of those jargons and direct them into right class. Due to limited time, this research focused on the stadium project. The training material was chosen from the room documents offered by Cox. To make the system more practical, we explored the common naming conflicts in design collaboration. As you know, people will not always follow the language in the same way. Hence, the system will put special emphasis on addressing these problematic expressions. Given the names from room documents, raw data will be cleaned and categorized to expand the diversity of corpus. Take sign counter as an example. After the cleaning process, sign and counter will be extracted to the corpus as a lexical entrance. As current word collection is unorganized and unrelated to each other, those irrelevant words need to be navigated into a defined class. WordNet, a lexical database of English, is suitable to retrieve the synonyms in this case. Given the room classification from industrial partner, words are connected based on their lexical relations under specified class. You can see here, the synonym set under the class toilet will help the machine to learn their semantic relevance. Take a fragment from the final corpus. The linkage of room names assists computer to accomplish the language understanding based on word sense similarity. For example, computer knows that changing place is synonyms with fitting room, but different from cold room. Hence, given this network, it can retrieve the similar phrases precisely, and the final corpus is delivered to help the linguistic analysis for the future standardization. In terms of the standardization processor, which is UNSW naming, the key to success is a workflow that is able to identify and standardize the input based on word sense. One major challenge is the recurrent usage of compound expressions in room naming, like there's a term called elevator lobby or allergen preparation. This synthetic language raises a difficulty for computer to understand. To make sure the system is flexible to standardize any random input from users, an iterative Python script is compiled to execute a thoroughly similarity check towards the input. This graph is a simple version of the previous one. One of the most important aspects here is the similarity computing. It's carried out through evaluating both word form and word sense relatedness. This is achieved by implementing fuzzy logic and word relation in corpus. Fuzzy logic is a logical system for getting the percentage of similarity rather than just give you true or false. Then, the final processor can accommodate any language format from users. After compiling the UNSW naming module, it's packaged as the web API. The delivered interface is through BIM software like Rivet or Rhino, connecting to the API. To test the efficacy of the interface, we generate a Grasshopper workflow to interact with the API and then give access to UZ naming module. In doing so, it works as a bridge to connect the UZ naming and Revit. To simplify this process, this script receives the inconsistent room name extracted from the Revit floor plan as the input. Then, by running the API inside, names will be standardized successfully as the output and sent back to Revit schedule. Here's an animation to help you understand how it works in the Revit. So basically, it's pretty simple. People just type the room name, and it will give the standard like the toilet towards WC. And with this given information, the people can use this standard class, like they can highlight the premium rooms with red color based on their class. And then you can output the class into the room schedule. So that is basically the result. Yeah, to sum up, all you need is just the API and your inconsistent room names. The system will standardize the room name automatically. So in order to test this method, we apply it to the room names in existing stadium projects from Cox. The system reached a significant accuracy rate as 95%. The average time on processing is only 0.3 seconds per input. With the help of interface, the standard class can be sent to Revit directly, which is a design collaboration in future. And in terms of the limitation, the data collection is insufficient at current stage, which means that the computer may risk difficulty to understand particular expressions that don't exist in the corpus. Moreover, it's challenging for computer to process too many words, like the term waste room, green, and industrial. The machine will confuse with the priority of those words and give incorrect result. To conclude the presentation, it will be good to talk about the future potential from this research. Given the time limitation, only so much could be done in regards to usability. As the concept in this research should be system agnostic, which means that user interface can be improved into simple access. Like we can devise a pop-up window for those workers who know nothing about computational stuff and help them to use this system more efficiently. Moreover, the architecture corpus could be developed further to assist precise naming standardization in other sectors like residential buildings, office, or hospital. Having said that, I think this research provides a new way that draw on the methods from computer science like NLP to innovate the ways of working in AEC industry. And it will be great to see future application of a system like this. And that's all. Thanks for listening. Thank you. Yeah. 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 Yeah, so for data collection, I basically extracted the names existing in the previous stadium projects, like the sign counter or elevator lobby. This already exists as the original room name and extracted as a benchmark. So help machine to understand, oh, this word is elevator lobby should be linked. They're not separate. So it will help people to, especially in the AEC industry, because it's different from normal dictionaries. Yeah. Yeah.
Would work on any other software, such as the connection between Revit to input them out of Revit, could also be out of Rhino, for example.
Yeah, it's the same because we just test whether the interface work. So we use this platform. We use the Rhino inside in Revit, and this Grasshopper workflow can also use to be in Rhino. Yeah. Yeah. Thank you. I just.
Jonathan.
Hi everyone. My research question is, in what ways can natural language process be applied to the auto-generalization system for BIM names in an architectural project to eliminate repetitive tasks? New digital technologies often lead to the development of new solutions for existing problems. For example, social media technologies led to social media network, which triggered the development of social media marketing concepts. So digital transformation is also impacting the architecture industry, most notably in relation to the uptake of building information modeling approaches in the production and the delivery of architectural projects. In the first part, I'm going to introduce what's building information modeling, what's the benefit of cloud cooperation in BIM-based projects, and the challenges of using BIM. Building information modeling BIM is an information model that's composed of completely sufficient information to support lifecycle management, which can provide the operating models and their parameters. Since the decades of development of BIM, it is common to see the use of mobile devices to access cloud BIM models at construction sites. Also, multidisciplinary actors can have a deeper cooperation online through their transparent information sharing. However, the lack of unified stand in classification of BIM objects increase the difficulty of finding target information in the BIM model. Imagine that you are a quality supervisor on the construction site. The workers just finished building the toilet. Now you are going to access the BIM model to check the details of it. So you type in toilet in your device. It appears a lot of results, but none of these are your target room. Then you may spend a lot of time to find the target information. Then finally, you find that the room tag of your target toilet is John, which is an informal name of toilet. This situation may get worse when the BIM model was created by the people from different nations, which means the annotation of each BIM object will be named by multi-languages. As you can see, items in the right side are stuck in a mess, making it difficult to find. BIM originally is introduced to increase the efficiency of communication between users, but in this situation, the efficiency of using BIM seems still slow. To solve this problem, I'm going to introduce an auto-generalization system for BIM names, talking about its objectives, how natural language process assists the system, and the outcomes. So the first target is to save the BIM user's time of finding target information, and second is to reduce the omission compared to the manual finding process. Our problem is that there's a lot of different words are describing the same meaning. In this case, natural language process can be introduced into this finding process by building an auto-classification system for BIM objects. NLP is a subfield of artificial intelligence, which studies the theories and methods that can achieve effective communication between humans and computers. By using walk-to-vector, which is using words as vectors to calculate and extract a neutral network of words. For example, this is the vector king and vector man. According to the rule, it can be found that this is king minus man vector and this is vector woman. So we can get king minus man plus woman equals queen, which can help computer understand the relationship between each word and get a simpler definition. Let's see another example. Coach. Coach has a meaning of teacher in the sports area. So sports can be an important attribute of the results. With Andrew, we define 5 important classifications. First, location. Second, size or relation. Third, sector. Fourth, ownership. And fifth, function. Now I'm going to introduce my workflow of the project. Since this system will be used in architecture field, the first step is to identify the function words in the phrases. So I find all the words meaning like room, space, facility, and find their more general callings as function list. Then I find 5 adjective words can describe the items in the function list, which are the SR list. And I find 5 antonyms of each items to enlarge the dataset and delete the duplicate data and the null data. By analyzing the example CSV files, I found that the ownership vector is related to the occupation. For example, staff list, coach office. Then I find a occupation dataset from GitHub and use entity recognition in natural language process field to quickly find all the entity of occupations. Then I append them into a list as our ownership list. Now let's see how the prototype works. You can choose multi-files into the system, and the program will return new CSV files which contain 5 vectors as our expect. So the workflow of the program should be first upload the Revit files. Instead of import CSV file straight away, extract the CSV file from the Revit file. Then import the data we need and clean the direction words, useless description words, and the null item in the dataset. By analyzing the original files from the Revit, there's a colon department, which is describe the sector of each room, so I matched it with the names of each BIM object and append them as our sector list. Then I detected each part of names of BIM object in the list we create from the pre-production stage and return full result vector information into result library. Another location information for now is just detecting the words external, internal, and shortcut of them to judge the location condition. The result I showed here is extract from the prototype result. As you can see, female officials wet area. The location information for now is null. Sector is amenities. Size and relationship is female. Ownership is officials, and the function is wet area. To test the system, I used a BIM project from Cox, which created in 2017, and by randomly choose 100 results, and if one of the 5 vectors is wrong, I marked whole result as wrong. And repeating the whole process 4 times, we can have an average accuracy at 82%, which is actually pretty high. For the future work, I'm now making whole function as a search engine plugin in Revit, and the plugin still has some bugs, so that I cannot show it until I figure out how to fix them. But I'm going to present the process of making it. So firstly, I'm using Revit Python shell, which is an IronPython console that runs inside of Revit, and using PyRevit, which allows users to create their own scripts. So this is the script, and we use WPF to get access to the XAML or WPF engine, and we will give it the path of this UI XAML file we created, and the engine will load it up and generate the components for the window and everything else. But before that, it needs to have access to the class myWindow, which also needs to be provided to the engine that we create these components attached to the window to set the properties and function that needs to handle the click on the button. So this class is like the code behind for the user interface. By using this framework, the function we want can be used in Revit as a plugin to help users automatically find the relevant information by different targets in BIM projects, which can save BIM users time of finding target information, reduce omissions, increase the accuracy of result, and allow them to work on more important design tasks, contributes to enhance productivity in the AEC industry. Thank you for listening.
Thank you for your presentation. With your order you presented, do you think you could address the industrial waste, no, the waste through green and industrial problem?
So sorry, I can't hear you.
Software to open or convert BTR files. And third one is the KUKA. KUKA can enable you to.
Daniel, mute yourself. Okay.
Yep.
So again, the question would be, Blair showed in her presentation that certain words, if they've been too long and too complex, like waste room, green, and industrial, are a problem to identify the phone computer. But you look like you have done a structure where you give certain rooms an order and classification of location, amenities, and so.
Yes.
Do you think your system would be able to understand longer and more complex definitions?
I think my system will just return like two characteristic in like one vector. Like it just return whatever it detected, then we can search that. Like instead of like more like it just like if it's more how should I say, like I just don't want the system miss anything, so it's just return two things and we can search that.
Okay. All right, thank you. Then let's go to the last presentation. I'm just going to rotate the screen around again so you can see the audience, and good to go.
Cool. Is it displaying my is it displaying the right side? As in, is it displaying the presentation side or my note side? Okay, cool. So yeah, hey everyone. My area of research was lighting and its management through adaptive computational means. This is to automate and optimize lighting in different spaces. Just some quick background research to help familiarize where I was going with my task. Lighting in spaces over the past decades hasn't seen much advancement through technological improvements, although they have already introduced an extensive amount of optimization and benefits in our design and architecture practice. We see the same arrangement in building spaces far too often, and while lighting fundamentally is a straightforward concept, it is never integrated and prioritized in earlier stages of development. A lot like many of the other components to a space that we've seen, they are integrated after the space is finished. I think lighting is a fundamental issue that affects the comfort and usability of all spaces, not just workspaces. So in figure 1.0 there, we have something similar to the red center. We have lights suspended from the ceiling, and we have cable management trays, I'd call them, just running across the ceiling, which isn't very pleasant to look at. So the second one of the background research, how are the handling processes for lighting? It is quite conventional to have static arrangements, which are very repetitive and done by hand. They're usually installed during the final furnishing stages of a space. And while these solutions do work, the newer computational methodologies, which can implement a whole myriad of extensive tools to help resolve and achieve specific solutions sort of catered to the space, can be done at a fraction of the time. Computer-aided design has also allowed for a new form of communication and engagement. This means the multitude of configurations and solutions are not only quickly achievable, but they're very widely understandable and can be easily communicated through graphs, diagrams, just very visual communication tools. So this forms my research question. How can the implementation of computational tools in lighting and its management enhance building performance, experience, and how will it integrate into today's design methodologies? So breaking that research question down into three main objectives, the first one being extraction of data from a floor plan into Rhino Grasshopper line work, which quantitative data can be used in scripting. The second one, automated dynamic lighting solutions optimized through Grasshopper simulations and scripting functions. The third one, visually communicate lighting solutions and management in workspaces and its implementation in real-world applications. So these are the outcomes I've been working towards. Some have achieved, and some given more time would be more achievable. So the first one being the optimization aspect. So given a space, all spaces as in rooms, workspaces, seating arrangements have been able to be categorized and given a dedicated lighting solution. In terms of efficiency, there is still a lot of manual correction that still needs to be done, like a lot of our work. The automation process is at about 75%, and most of that is the conversion from more analog floor plan done prior to digital means that needs to be converted. In terms of the application, it should be fairly implementable in the real world, given that someone wants to use it. With further development, I do expect it to be a lot more polished. So some literature review are things that have really helped direct my research. The first one being the light will not be used as much in spaces where abundance of natural lighting exists, or a space is used for a purpose that does not require much light, like stairways or storages. The second one is there's an opportunity to be more ecologically and economically friendly. Sharing lights between desks or removing lights where they're positioned closer to windows where there's natural light. Mark Luther, in a 2017 study, was called the application of daylighting software for case study design buildings. It was a study over several different spaces, and he says that the use of even the simplest software can guide and inform design decisions in daylighting. So I've got a table here. It's a lux level table. Lux is basically a measurement of light, or lumens is a measurement of light, it's a unit. So it basically says different amounts of lights that we can refer to that are deemed adequate in different spaces. So the tool does aim to be reusable and adaptive. It's a dynamic tool, and it's meant to adapt to different geometries and commercial spaces to identify, arrange, and construct the most efficient and organized arrangement of lights and its cables. So here we have my workflow diagram. The research will be achieved through an action research format. The work cycle enables successful outcomes through evaluations of various iterations through the project. Enhancements are made to each iteration, and further analysis is done to achieve a successful end solution. Traditionally, this process requires 3 circular steps before conclusion can be reached. It requires the planning, the implementation, and experimentation, and then the analysis and evaluation. And it just cycles until a good end result can be achieved. So breaking down that workflow diagram, that first one was to obtain a recreation of the space. Like most of us, I'm working in Rhino and Grasshopper. We have a generic floor plan in a PNG format, and I've gone with a picture format because most platforms where a space is created in can export to a picture format. So here we have the recreation in the bottom image in Rhino. And that was done by using the off-the-shelf component image sampler. It's within Grasshopper, and it recreates geometry based on color contrast and brightness. I've changed the settings to round all gradients on the image to 0, meaning that it's white, and 1, meaning it's black. And it doesn't create lines, it creates points. So the points need to be cleaned up, and from there, you can accurately recreate the space. So once the space has been recreated and the static data is arranged, like seating positions, work desk spaces, room size and stuff like that, the more dynamic stuff, the stuff that populates the space can start being catered for. So that's the graphical illustration of like desk arrangements, seating plans, and the green circle illustrates a direct overview of a light projection. So it's a very basic system at this point. The light is just being projected onto the center of each seating position or desk space. This is where I include my second data set to further the optimization process. This is to do with lux simulations. So the platform I use for daylight simulation and light analysis is Ladybug and Honeybee. This package plugin is freely accessible, and how it works is the geometry is basically imported into the Ladybug engine. And you can also give it a location or geographical file, and it does a simulation of the space at the actual location you give it. This is quite hard to use in my actual final script because the data is fairly hard to convert to a quantitative or a numerical value, but I'll touch on that more later. This is where I struggled with the conversion to actual numbers. So given that this does work in the future, and I can gather like a table of values from the analysis, we can go ahead and use more functions to sort of filter and categorize which rooms require more attention or less lighting and such. Dataset 3, parametric rules to address different lighting specifications. In this step, I look at the more technical side to lighting and such. So the first solution I tried to configure in was LED downlights. I feel like they are the least intrusive, they're very quick to install, and they have really good output, 700 to 900 lumens. Most manufacturers have specified that the, Most manufacturers have specified that the lighting spread and focus is determined by how high the ceiling is, and that also determines how much you should spread it. So in most office spaces here, the ceiling height is predominantly 2.7 meters, and this means the light focus is at a 2-meter diameter. Using these numbers, we can create a linear scale that adapts to different ceiling heights in the script. So again, if you were to put this tool into different spaces, it would automatically adjust the light projection. And in this way, we have established in a 2.7 meter high space, the downlights have to be about 1.5 meters apart to ensure some overlap and good coverage. So the second iteration takes a different route to address, to integrate the more technical aspects of the lighting. The first iteration administers a very linear solution, and that was just to project light over each space. It doesn't really include how much light needs to be integrated and stuff like that. So other dynamic parameters and data were incorporated here to further the optimization. Other factors and reworked inputs, mathematical algorithms were introduced in the second iteration to ensure that the projected lighting coverage is sufficient. So using the actual geometry instead of points, so if there's a couch at a certain point, you use the actual couch's geometry, so like how much space is there, or like a desk size. You'd incorporate that rather than a point to ensure visually you can see that the light covers that space. So here is an example of one of the algorithms that I used. So essentially you have the points at each desk is placed, but unfortunately you can't generate a rectangle. So the rectangle is meant to be the desk. You can't generate that from the center. Grasshopper only allows you to create a rectangle from a corner. So it's something I learned in the earlier years of computational design with Andrew. It's just using 2 domains to basically expand a rectangle from a center point. And it's important to maintain the accuracy of the floor plan because a lot of the results are very visual. It's very difficult to communicate what a successful lighting sort of solution is. Here I introduce some more lighting options. Stuff like track lighting where multiple lights are angled from a center point. And that's just to further the application of this tool. For different clients or spaces, different lighting is required. In this space here, this is basically the first successful optimization, and the tool is, we can visually see the tool has successfully covered each different desk space, desk spaces of different orientations, and it does this by utilizing a boundary box. It calculates the area and then sorts that out into different categories, and then different amounts of lighting are applied to those different spaces. Here's a more of a visual representation of the light coverage. You have tracked lighting in some of the spaces, and you have downlights. The cones of 3 are the downlights, and the ones which project from the center are the track lights. So in the second iteration, it calculates the area and adapts the new geometry sizing and positioning. It calculates workspace, smaller spaces, use less lighting, etc. So you also have the option of picking that second lighting option, and you can obviously integrate more down the line. So this is more about the technical application in a real life sort of industry. So it was important to sort of understand the electrical system and how it would actually be incorporated into a space. So fundamentally, there are 2 methods of daisy chaining electrical components, and that is either in series or parallel. So a light bulb can be said to have a positive and a ground, and in a series circuit, they are joined through interchanging the positive and the ground. The current passes through the positive of the first bulb and out of the ground where the positive of the next bulb uses the leftover energy. And so over a longer circuit, it would inevitably get dimmer. So that's not preferred in this. So this is where a parallel circuit comes into play. It basically is linking all the positives and the ground of the light bulbs. And so if a light bulb in the system was to break, it's not going to interrupt the rest of the circuit. So understanding this, we are able to implement a very basic parallel circuit, which just means as long as a 2-core wire is thick enough to support the amount of amperage being drawn at the maximum load. So when all the lights are on at the same time, a single dual-core cable that can support the amount of power that's required can be run around the ceiling in this parallel circuit. The notion of modularity and efficiency can be furthered by adding a splitter at each node, sort of like a power board. So if you were to add a splitter at each light, instead of running cables sort of in an S shape or randomly through a ceiling, you can sort of spider them out, which means you have shorter routing and quick connections, room for expansion in the future. This is a very basic approach to finding the best method of routing. Basically, because the attic in between floors is quite unobstructed, I think preemptively generating a wiring diagram to simplify and cheapen installation, make it more organized, is quite a good thing to implement, to integrate into the practice. Basically, the same point location of each light is re-referenced, and you polyline the closest points together. So this means you have 2 routes or 2 options of which light to connect to. So it basically tells you which 2 lights are closest to the one you're trying to hook up. So evaluations and limitations of the tool currently. As the overarching aim of the project was to develop a lighting optimization tool to be applicable to work in spaces, the findings have mostly been successful. I say this because the outcome is visually straightforward and allows for engagement from older users with less experience, as well as newcomers to a changing era. My first objective was to convert the different design platform outputs into a Rhino medium, which Grasshopper can then utilize. Manual filtering and sorting is still very necessary here, but given more time, more fully autonomous processes should be able to be developed here. And I think this is quite important because we really should be leveraging the 3D space and simulations for proper outcomes here. The second objective was to utilize inherent data or embedded data in the floor plan that's already there. So things like window sizes, seating positions, desk sizes. By pulling these different data sets and putting them through different algorithms, you can really optimize the space. One of the biggest shortcomings to the experiment, undeniably, there were a lot of issues during this process, but the biggest one was the absence of honeybee and ladybug data in the script. And this was due to just me being unable to convert the simulation or the graphical information into something numerical, something that Grasshopper can accept. If that was later down the line possible, I'm sure we could further dispatch and categorize those. So innovative computational methods for lighting optimization and management in spaces allow for quick and accurate solutions, unparalleled with anything previously for the last couple of decades. The parametric and dynamic nature of such tools envelope allow for the industry-wide applicability and can be understood by designers of multiple sorts. It also incorporates further complexity problem-solving capabilities. So the modern computational tool collection provides optimal predictions with rooms for more configurability to each client or space's needs, and hence showcases extensive functionality, making it imperative to today's industry. That was it. Thanks for listening to my speech.
Hi, Kevin. Thanks for the presentation. I think that you have developed a tool that is really useful and is going to save a lot of time to designers. I have a couple of questions, and the first one is, I can see that you have applied the tool mainly to office buildings and focusing lights in the work areas. Do you think that it would be possible to apply, for example, to residential buildings when maybe you want an indirect light in the living rooms, or to other spaces like museums that have very specific requirements for the lighting, for paintings, for example, or if you want to illuminate or light a sculpture from the floor or something like that? Do you think that it could be possible to implement those different options?
Yep. Yeah, understood. Yeah, I think currently there's still a lot of more work to be done, but given the nature of these computational tools, I think it is very possible to create more rules and configurations that can be applied. So I think in the same way that we're projecting light downwards onto workspaces, it shouldn't be an issue to project them at an angle onto a wall or from the ground back up onto a wall.
All right, thank you. So for all of you remotely, pity that you couldn't really join us for the pleasant part now of the whole day of going and having a drink. But by all means, go to the fridge, serve yourself one, put your feet up, go to bed, have a good break. Thank you to you all for being our students for the last 3 years in computation design. It was a great pleasure to teach you. Stay in contact, don't get strangers, and we hope we see each other one day again here on campus or elsewhere. Okay? Thank you. Bye-bye.
Thanks. See ya.
So for the ones who've been here physically, hooray. Let's go downstairs, catch up with the other ones, and we're going to go for the square roundhouse. I don't know. I know, like, you now if there was now if then hey, good to see you again. Exactly, yeah. That's what's in the audience. Back watch everyone kind of do we do a yeah, we should do a photo for sure. So we could yeah. Come to the front.
as you know, because that's what really collaborative learning and its core principles of engaging stakeholders, users, and many of your and to that end, industry is and overall really great relationship with industry, the agency, but also now nationally. So the first thank you, I guess I want to give anyone who's on that, is to our industry collaborators and say, hey, Mark, please become physically today. So thank you very much. Consulting, top architecture and both right? That's at current architect, Apple, and also R2. So what's really impressive about that is that I'm able to look at problems we've solved in the world beyond the AEC and now engaging beyond the AEC. HDR software so get the six it is really quite precious any and to take time as related to and especially and also very clever because as you're all aware, organizations have incredibly strange set of circumstances and very quickly so that it has to do with that. And while they may have sort of been something around the edges, so you guys are you're really the that it is right. Now, thank you to you guys. What a tremendous effort. So there's two things that I think is so your circumstances. The first thing is that you are a group from semesters. So you came in on semesters, and then your last 2 years of your degree done semesters. So this experience is kind of changed here at the university, and also here in practice and you are reviewing it. Yeah, and you say that, and you participated and you've been happy. Generally, when I spoke to you and really friendly and there's not been a lot of, there's a word I'm looking for, I'm not talking about the word, but yeah, you're close to it at least very engaging. And I don't think that can be underestimated. Of that shift to online learning, very isolated, very today's circumstances. I think a mix of quite scary and very roller coastery up and down. We are affected of course, the other people we need to great personality voice. Like, what is that word? Charismatic. No, that's not it.
I don't send you this,